Hello and good afternoon friends, welcome to CEC-UGC live lecture. Dear friends, today in this session we are going to talk about application of aerosol, optical depth for estimation of size segregated particulate matters in Delhi, and for this we have in our studios Dr. Arun Srivastav. He is Assistant Professor in School of Environmental Studies, JNU, that is Jawaharlal Nehru University. He is MPhil and PhD from JNU, as well as he has done his Masters from Allahabad University. He is basically working on air pollution and he has immense knowledge in this very topic. That's why he is today with us in our studios. So first of all, I would like to welcome Dr. Arun Srivastav. So welcome to the EduSet lecture, and I hope all the students who might be watching us would be benefit from this particular lecture. So over to you, sir.
Thank you very much. The topic of my presentation will be application of aerosol optical depth for the estimation of size segregated particulate matters in Delhi. However, before I go into the details of this very topic, I must give you some information about the air pollution. Everyone knows what is the air pollution, and there are various methods for the estimation of air pollution. But the major problem with so far the methods that people have been applying is it is very time taking, expensive, and it is confined to a very localized area. So to overcome those problems, a novel way of estimation of air pollution method was developed that is based upon the satellite data or satellite retrievals. So this aerosol optical depth is basically one of the parts of that satellite estimation of air pollution. I must show you this picture, and in these two pictures you see one is very clear, another is very hazy. It is basically because of the air pollution. The picture at the left hand side, it is the picture of a pollution free day, while the picture at the right hand side is when it was highly polluted. It is of the Shanghai city. The same type of situation is here in another picture. So it was estimated that instead of monitoring the air pollution at some localized place, it is very much essential to know the pollution level of an entire city or a big area. And for that purpose, the different methods that can be applied are these three. One is LiDAR. LiDAR is basically, the full form of LiDAR is light imaging detecting and ranging. This can be applied from the satellite as well as from the ground based methods. Another is satellite observation directly from the satellites, and the third one is AOD. It is basically applied at the ground base, at the ground level. Satellites uses different three types of wavelengths. One is below 4 micrometer, that is also known as solar backscatter, and this is basically the light which directly comes from the solar sun and reflects back from the pollution, and it is retrieved by the satellites. The second is thermal infrared emission. This is between 4 to 50 micrometer. This one is basically the rays or the electromagnetic radiation which is emitted by the earth after absorbing the solar energy throughout the day. And the third one is the energy itself is emitted by the satellites and then retrieved, and with the help of that the informations are gathered. So this is how the schematic, how the things work. In the right hand side you can see the satellite which is using different three types of wavelength. One is which is being reflected from the ground or from the object, that is I4, and later on it is becoming I5, and the next one is I6 which is emitted by the earth and later on by the object, and in the form of I7 is getting absorbed by the satellite, and one is I2. So there are different three type of wavelengths that can be received by the satellites and can be analyzed for the estimation of air pollution. And these are some of the satellites, some of the satellites which uses or which can give information about the air pollution. There are various satellites, there are many satellites actually, but it is not all the satellites gives information about the air pollution, some of them, and this is listed here. These are listed here, and I think I must skip this. This one picture is basically given by satellite. You can see the different color, and it is basically of the gaseous pollutants. You can see India, Africa, and some part of Europe are highly polluted. Even the same thing is with the United States. And the color coding is basically it represents the concentration of various pollutants. The red one is the highest pollution. It shows the highest pollution. Some of the portions like in China, which is near the Shanghai, that is in red. This is at the right hand side in the China, that is red. It can be considered as the hot spot for the gaseous pollutant. This information is actually given by satellite. Similarly here, it is the map of world, the entire world, and this is basically for the NOx. You can see the places encircled or the hot spots for the NOx pollution. India is one among them, and China again, Europe, United States, and some portion of the South Africa. Now, coming back to the AOD, actually AOD can be measured or can be estimated by two different methods, two different instruments. They are actually spectroradiometer, and the next one is sun photometer. A spectroradiometer is basically, it measures the amount of light that a sample absorbs, and the instrument actually operates by passing a beam of light through a sample and measuring the intensity of light which reaches the detector. And sun photometer is basically an instrument which measures the direct sunlight and thereby aerosol optical depth. That is actually the topic of today's lecture. Now coming to the optical depth. What is optical depth actually? Optical depth is basically basically a quantity which is expressed by the light that is being removed from a beam by scattering or by absorption when it passes through a medium. Like here you can see a medium that is in light blue color, and the light which is of red color is having the intensity of I0, is passing by the medium having a width of L, small l, and it is coming out having its color decreased, intensity of the color is decreased, and similarly the intensity of the light is also decreased. So this relationship can be given by a law that is known as Lambert-Beers-Boger law, that is I upon I0 is equal to e to the power minus L tau. This L is basically width of the medium, but in our case when it is atmosphere, this L is not there. So how it can be represented? This L can be represented or given in the form of jet sun, and this jet sun is basically L here. That is also known as air mass. Here now the expression can be given in the form of this, that is I lambda. I lambda is basically the intensity of the rays after passing through the medium. I0 is the intensity at the source, and tau is the optical depth, while this m, that is jet sun, is basically the air mass. And finally, with the help of this expression, the aerosol optical depth can be estimated, that is tau lambda is equal to 1 upon m ln I lambda upon I0. Now, the major problem with the aerosol optical, because here we are concerned with the air pollution or aerosols which are of mostly anthropogenic origin, but there are many other particles which are natural that cannot be considered as the air pollutants, that can also interfere with our study. They are Rayleigh scattering. Rayleigh scattering is basically the scattering of the light by the gaseous particles, or those atoms or molecules which are very, very small as far as the light's wavelength is concerned. These are naturally occurring various gases. Then gaseous particles with heavy diameter, with having higher molecules, they are ozone, carbon dioxide and nitrogen dioxide, and the next one is water vapor. So these three, 1, 3 and 4, they are basically naturally occurring, and aerosol is basically the air pollution. So now the entire aerosol optical depth becomes the sum total of Rayleigh optical depth, gaseous optical depth, water vapor optical depth and the aerosol optical depth. So if we have to calculate the aerosol optical depth, so we will have to subtract the remaining 3 from the total aerosol optical depth. So, finally this aerosol optical depth is equal to the total aerosol optical depth minus the Rayleigh optical depth, gaseous optical depth and water vapor optical depth. But it is very difficult to quantify these 3 values and subtract it. So, instead of that, we actually choose the wavelength which is outside of the gaseous band. Like we can see from this, suppose there is a particle having a diameter d. If the wavelength of the light is lesser than d, lesser than the particle, that is in yellow color, so what will happen? The light will reflect back, and if it is comparable to the d, almost aggregate to the d, aggregate to the particle, that is in light green color, so what will happen? The particle, the wave will scatter in various directions. And the third one, what happens when the diameter of the particle is smaller than the wavelength? The light passes. I mean, this basically this particle behaves as a transparent medium for the particle. Coming back to the original one. So, just to overcome that problem, what do? We actually select the channels or the wavelength which is outside of the gaseous band, and we do monitoring when it is totally cloud free, means the water vapor is more or less completely absent, and also we try to select the wavelength band which is beyond the Rayleigh band. So, finally what we have, that is aerosol optical depth or the AOD, which can give us information about the air pollution. Now, we can again have see some definition of aerosol optical depth. Aerosol optical depth is basically a quantitative measure of the extinction of solar radiation by aerosol scattering and absorption between the point of observation and the top of the atmosphere. It is a measure of the integrated columnar aerosol load and the single most important parameter for evaluating the direct radiative forcing. AOD can be determined from the ground through measurements of the spectral transmission of solar radiation through the atmosphere using rather simple and relatively inexpensive instruments pointed directly at the sun, called sun photometer or filter radiometers. What are the applications of this aerosol optical depth? The number one is atmospheric correction of remotely sensed surface features, monitoring of source and sinks of the aerosol, monitoring of volcanic eruption and forest fires, radiative transfer model, air quality, health and environment, earth radiation budget and climate change. But the major problem which we actually face while monitoring the aerosol optical depth, the particles present in the atmosphere are highly variable as far as the size is concerned. It can start from the size of few nanometers to up to 100 microns. So, it is a highly variable as far as in respect to size, and their number with the size distribution is also very uncertain. It is not that some amount of number is a fixed diameter having this can have this amount of numbers, and some particular size particle will be of that number. So, it is also highly uncertain as far as their size distribution is concerned. And the third one is their composition. Composition is also highly uncertain. It is extremely variable in space and time. Now, to overcome this problem, a novel method was invented, and that was basically termed as angstrom turbidity formula. Here it is tau lambda is equal to beta multiplied by lambda to the power minus alpha, where lambda is the wavelength in microns of that particular wavelength of interest, beta is known as angstrom's turbidity coefficient, while alpha is known as wavelength exponent. So, in this particular study, actually we usually alpha varies between a range of 0.5 to 2.5, and when the atmosphere is very natural, I mean it is pollution free, it can have a value of 1.3 plus minus 0.5. And what happens when alpha is very high or the alpha's value are coming very large? If the alpha's value are very large, provided the tau value for larger wavelength is much smaller than the tau value for a smaller wavelength, it shows that the distribution is, the ratio of smaller particles are very much. I mean, the distribution is biased towards the smaller particles. And what happens when the value of alpha is small, provided the AOD value for larger wavelength is more or less equal to the AOD value for the smaller wavelength. It implies that the larger particles or the particles having larger diameters dominate the distribution. When beta is less than 0.1, it means that the atmosphere is relatively clear, and when beta is greater than 0.2, it shows that it is hazy. I mean, pollution is there. How this alpha and beta can be calculated? Alpha can be calculated when we employ two different wavelengths. Suppose if we are implying one wavelength, that is known as, if it is lambda 1, so we will have one equation, that is tau lambda 1 is equal to beta multiplied by lambda 1 to the power minus alpha, and similarly tau lambda 2 is equal to beta multiplied by lambda 2 to the power minus alpha. So with the help of this, we can have a relationship, and finally we can get the value of alpha, that is alpha equal to ln log tau lambda 1 over lambda tau lambda 2 upon ln lambda 2 over lambda 1. And beta can be calculated from either wavelength, that is tau lambda 1 is equal into lambda 1 to the power alpha, or tau lambda 2 multiplied by lambda 2 to the power alpha. This one is the instrument that actually gave us the value of AOD. It is known as sun photometer. It is manufactured in the United States from the Solar Light Company. What do? We actually point this instrument towards the sun, and in the center, at the surface of this instrument, we are seeing a circular thing, and here we observe the sun, the point sun in the form of point, and when it is very sharp, the image is sharp, we press the enter and we get the AOD of that particular time of that particular place. This is the schematic diagram of sun photometer. There are various parts of the instruments. It includes recorder, filter, amplifier, detector, lens, tube for preventing skylight, and the place from where the sunlight enters into the instruments. That is in the towards the right hand side. And in our study, actually, we employed different 5 wavelengths, that is 380 nanometer, 500 nanometers, 675 nanometers, 936 nanometer, and 1020 nanometers. In fact, here there are different 8 wavelengths shown. So one can have the combination of any 5 among these different 8 wavelengths. In this particular case, out of those 5 wavelengths that we selected, the 936 and 1020 actually was used for the water vapor, and these are the sampling places or the sites where we have done our monitoring. There were different 3 sites where the monitoring was carried out, that is Jawaharlal Nehru University, Patel Nagar, and Mukherjee Nagar. It is represented in the map as S1, S2, and S3. You can look at it. This PN is basically at PN is Patel Nagar, while MN in the map is Mukherjee Nagar, and JNU is Jawaharlal Nehru University. Excuse me, I must go to the next. In this particular case, the refractive index what we have chosen is 1.45. It is taken, and the radius that we used for our study was between 0.1 to 7.8 micron, and the results that we got were AOD, that is aerosol optical depth for different wavelengths, daily variation of angstrom exponent alpha, turbidity coefficient, diurnal variation of AOD 500 and angstrom wavelength exponent, that is alpha, as well as daily variation of columnar number side distribution of aerosols. So, here is the result of AOD of various days at JNU. The sampling at JNU was carried out in the month of February and March, and here it is the result is of Patel Nagar, and here the sampling was carried out in the month of May, and this is of Mukherjee Nagar. For 3 days, actually the sampling was carried out for 3 days, again in the month of May. Our results show that the variation of this aerosol optical depth is basically, it follows the Mie scattering theory, and in fact it should be, it must be there. So, it validates our result also. One more thing I must mention here is that this the wavelength optical depth or at shorter wavelength, or in other words you can say that there is a strong spectral dependence of the optical depth at shorter wavelength than the normal than the longer wavelength. It means that the finer particles dominate the distribution, and the magnitude of AOD keeps on decreasing with the increase in wavelength of AOD, with increase in wavelength of the EM waves each day of observation. I think I must skip this. Yes, our results show the inverse relationship between wavelength exponent and turbidity coefficient. It means when it is highly polluted, then the distribution or the pollution level is mainly because of the finer particles. When it is less polluted, the distribution is dominated by the larger particles. It means then whatever the pollution we are observing, if it is intense, it is mainly because of the finer particles, and these were the results that already been carried out at various places. So, it was in the total conformity with the results. Here one can see there is an inverse relationship between alpha and beta, that is in blue color and red color, at more or less all the places except at Patel Nagar. The situation is a little different, and our results also found that there was a good association between alpha beta values and AOD 500 values. Daily variation of alpha beta do not show any definite pattern over any site, which can be attributed to high variation in daily synoptical meteorological parameters and aerosol loading over study area. I think I must skip this, it is not needed. Yes, one more interesting result I must show, that alpha increases during the forenoon, followed by a slight decrease during 12 to 1 p.m., which again increases during 1:30 p.m. to 2:30 p.m., and finally it decreases as evening progresses, except on 4th and 5th March. There were some unusualities on 4th and 5th March. Okay. One more result that I would like to show is its number distribution. So, here in our particular case, instead of number of aerosols, we have presented it in the form of dNc upon dlnr. dlnr basically represents the number of particles per unit area per unit log radius interval in the atmospheric vertical column. Daily mean variation of aerosol distribution over all sites exhibits power law side distribution, that is Junge's distribution. So, this is the results that we have got on various days at JNU, at Mukherjee Nagar and at Patel Nagar. and after getting an equation, we obtained the R square values, and in all the cases we have found R square values more than 0.9. It means our results are valid in very much conformity, and after integrating those results in different two size ranges, we have, and that is between 0.1 to 2.5 and 2.5 to 7.5, we have got different two side distributions, and one we termed as coarse coarse particles, that is actually 2.5 to 7.8. It means the particles between the size range of 2.5 to 7.8 were considered as coarse particles, while the particles having the size between 0.1 to 2.5 microns were considered as fine particles. These are the results that we have obtained on different days. That is, here with these results you can see the distribution is mainly dominated by the fine mode particles, more or less all the days, that is on 26th, 27th, 28th February. Even here on 28th February, the fine particles have over dominated the distribution. Again, we can see on 3rd March, 4th March and 6th March, it is more or less the complete dominance of fine particles, that is more than 90%, and in one case it is approximately 98 or 99%, and that is on 3rd March. At JNU, fine mode fractions has over dominated, while on 3rd, 4th and 5th March, the contribution of coarse mode fraction has been negligibly small. This infers the presence of only accumulation mode, that is between 0.1 to 1 micron particles. On 4th March, high AOD, that is 500, AOD 500 and high beta values with relatively high fine mode fractions indicates the presence of both dust storm and anthropogenic aerosols over JNU. Interestingly, on 6th March, low AOD values, low AOD 500 and low beta values and moderate alpha values coupled with the dominance of fine particles point towards the dispersion process of dust aerosols, which was observed on the previous day, that is on 5th March. That was actually on 5th March. This is of Mukherjee Nagar. So, the result shows that about 99% of fine mode fractions of aerosols were observed on 5th, 6th and 8th May, which can be basically attributed to aerosol genesis by the local vehicular and other anthropogenic emissions over Mukherjee Nagar. However, on 10th May, relatively more coarse particles with higher AOD 500 and high beta values clearly indicate the occurrence of dust storm. This is the result of Patel Nagar, that was done actually on 13th, 14th and 15th May. Here more or less it is over dominated or completely dominated by the fine mode particles. We can say that high fine mode fractions, about 99% aerosols over Patel Nagar with high AOD 500 and high beta values can be attributed to the presence of hazy layers. These hazy layers may have been formed by anthropogenic emissions of nearby small scale industries. In fact, Patel Nagar has many small scale industries as well as vehicles, and fine mode is basically dominated by the particles coming from the southwest direction. Now I come to the conclusions. The magnitude of AOD decreases with increase in wavelength on each day of observations. Relatively higher values of AOD over Mukherjee Nagar and Patel Nagar as compared to JNU can be attributed to the fact that JNU experiences a lesser degree of industrial and vehicular pollution than the other two observation sites. The angstrom parameters of alpha and beta, indicators of aerosol site distribution, show an inverse relationship. This study also revealed a good relationship or a good association of alpha and beta with AOD 500 values. The trend of diurnal aerosol variation of AOD and alpha over JNU is very much associated with the vehicular emission. Normally, in all the observations, high AOD 500 values are associated with lower wind speed and vice versa. Daily mean variation of aerosol site distribution over all the sites show power law distribution, that is Chunge's law distribution. Results of coarse mode fraction and fine mode fractions show dominance of fine mode aerosol particles over the study area, which reveals vehicular and industrial emission as a main source of pollution in Delhi. And in fact, our work has been published in some good journals. Here is one of that. This work was actually published in Sustainable Environment Research, and another journal, that is Aerosol and Air Quality Research, and this is also a very good journal. Thank you. I think I am done, ma'am.
Definitely, sir. You have been discussing a lot about the aerosols optical depth, but if we talk in the plain terms or in easy terms, what aerosols are when we're talking about air pollution?
Well, aerosols, as far as its definition is concerned, we can say that aerosols are the tiniest particles or very small particles, maybe of liquid or solid, or sometimes multi-phased, and they are basically suspended in any medium, and here in this particular case the medium is atmosphere or the air. So basically whatever the pollution that we observe, these are basically aerosols, and the tiny particles which comes from various processes, and the processes can be of vehicular emissions or from the industrial emissions or from the domestic emissions.
If we talk about these aerosols, definitely they are constituting or we can say that they are contributing for the pollution.
Yeah.
But if we talk about the composition of the aerosols, as you said that we tend to get these aerosols from different mediums. But if we talk about the composition, is there a definite composition of this aerosols?
Yes. The composition of the aerosols are highly variable as far as the space and time is concerned. I mean, at some place, suppose we are in Delhi at let it be Connaught Place, their composition can vary from time to time. Maybe in the morning the composition can be different, in the evening can be different, and in the night can be different. As well as in space. Suppose we are at Connaught Place, we are finding some different type of composition. If we move some distance away, let it be ITO, the composition again can be different than that of Connaught Place. This is what is the reason behind this. The major reason behind this is the sources where it is coming from. And let it be, as far as Delhi is concerned, the major source of pollution is vehicles or the vehicles. Industries also contribute, but not that much as much the vehicles. And among vehicles, the different type of vehicles, I mean the different type of fuel that they run on, it is also one of the major factors for the composition. Suppose a vehicle is running on diesel, the aerosols generated by that vehicles, its composition will be different by the from the aerosols which are being emitted from a vehicle which is running on petrol or on CNG. Or if you go to some other places like small places of UP or even in Bihar, you will find that their vehicles are, especially the tempos, etc., sometimes they run it on kerosene. So the aerosols which are generated by kerosenes, their composition can again be different than those generated by diesel or petrol. And Apart from this, if the aerosols are being generated from the industries, it can again be different. And it also depends upon the various industries, what type of industries they are. If it is a varnish or paint industry, the composition can highly be biased towards some heavy metals like chromium, nickel, cadmium, because color in the paints etc. varies on the basis of the different metals that they use. So the composition is highly variable in space and time. One more thing I would like to say. This composition also plays a very crucial role as far as the human health is concerned, because ultimately these aerosols are breathed by us. So if the composition is of such nature that it contains some heavy metals or toxic metals, it can be more injurious to our health.
That's why it is often said that people residing near the industries tend to
They are
get
more prone to-
particular diseases because
Yes,
of the
yes,
heavy
yes.
metals or the pollutant it is carrying. If we talk about the, as you said in the lecture, that they have definite size.
Yes.
So what is the definite size? Do this size also varies when we talk about distinction and
Yes,
variability?
yes, yes. The different size has actually a range. It is not some fixed size. It starts from nano scale, that is 10 to the minus 9 meter. It is very, very tiny. It cannot be seen by bare eyes. Even it can't be seen properly with the help of microscope. To visualize nanoparticles, we must employ some electron microscope. So their range basically starts from the nano size, and it can go up to 100 micron. 100 micron is also not enough size that can easily be seen by bare eyes, but it can be seen when it is reflecting some light or some direct beam of light is falling upon it. We always see, suppose there is a hole in the wall and some sunlight is coming through that particular in a pointed structure, pointed manner. So we see the particles spark, you know. So these are basically micron sized particles that can be seen under specific circumstances or with the help of microscope.
And you talked about, you segregated and you elaborated this topic, not confined to only aerosols. You defined it as aerosol optical depth. If we are talking about aerosol, then what is this optical depth?
Yes, I must elaborate it. Optical depth, I told you that measuring so far, before we go into the details of optical depth, I must say how the this air pollution or aerosols were monitored initially. There were some methods for monitoring of aerosol. That was basically a pump method, or it is also known as sampler. So what do? We actually keep some filter papers and we pass the air through it, and after some times the pollutants present in the atmosphere get deposited upon those filter papers, and with the help of that we actually estimate the amount of pollution. So finally, suppose if we are monitoring here, or if we are employing that method here, we will be having an idea of air pollution of this particular area. If we move some 10 kilometers or 5 kilometers away from this place, the same air pollution level will not be valid there. It might be different. So a need was, people thought that there is a need to estimate the aerosols or air pollution on a synoptic level or on a large area. So one method was that you will have to install a sampler here, monitor it here, go there 100 or 200 meters, again monitor it there, then again 200. So in 5 kilometers you will have to monitor it at either 5 or 10 places. So it is an inexpensive, it is again a very expensive and time taking process. Again another problem is that for this type of monitoring we will have to wait for at least 24 hours. So the monitoring has to be carried out for 24 hours, then only we get the result. But as far as aerosol optical depth is concerned, the biggest advantage of this method is we can estimate the air pollution in a very short span of time, sometimes immediately, and on a large scale. So it basically, it is not localized at some place, but it gives the information of a extended area. So now coming, what is aerosol optical depth? So just to make you understand, I must tell you, suppose we are passing a light through some object. So what will happen? There are three processes. There are three possibilities actually. The light will be absorbed by that object, number one. The light will be completely reflected back by that object, and the third possibility is the light will be passed through that. So there are three possibilities, but the nature of light that is basically coming out after striking the object will be different. Do you understand? So what will happen? The light which is coming out after striking the object will have a different character as far as intensity and quantity is concerned. So the changed light which is coming out, that actually gives you information, can give you information about the object. Similarly here, the optical depth, what we are talking about, and the object. Object is basically the different particles, the aerosols or the pollutants that are present in the atmosphere. What happens? Light strike upon that, it either passes or it gets absorbed or it gets reflected back, and then it is sensed by some sensor. So the information what we are achieving is changed information of the light that actually struck at the beginning. So that change information can give you information about the particles or the pollutants that are present in the atmosphere.
That is, we can say that it gives the full total dimension of that particular
Yes,
particle,
yes,
that
as well as
what
the
is the
nature, yes.
intensity, whether it is going to be very harmful or less harmful or not at all harmful. Now sir, you raised certain terms like CMF and FMF. Please elaborate them in detail.
In fact, I told you that when the object, coming back to the object thing, so suppose light strikes upon an object. So if the wavelength of the light is smaller enough than the diameter of the object, so in that case what will happen? Light will be completely reflected back. If the diameter of the object is equal to, more or less equal to the wavelength of the light, so there are some possibilities that the light will be scattered after striking the object. If the diameter of the object is smaller than the wavelength of the light, so in that particular case what will happen? The light will pass through that object. So these three things, these three possibilities can give you information about the diameter of the object or what is the size of the particles. So in that part it is not possible, because atmosphere, I told you, the size of the particles starts from nano size ranges to up to 100 microns. It is highly variable in space and time. So what we can have, we can divide it into two different blocks actually, giving one coarse mode particles, another is fine mode particles. Yani ki one which is between 0.1 micron to up to 2.5 micron can be termed as fine mode fraction, and the one which is between 2.5 to up to 7.6 or up to 8 micron, that will be coarse mode particle. It actually has some implication upon the health also, because the particles which are very small can go deep into our lungs, and the particles which are not very small, the chances of those particles getting lodged deep into our lungs is less. So this is why we segregate the particles in different size ranges. Here in this particular case, we have segregated into two different size ranges, that is coarse mode fractions as well as the fine mode fractions.
On the basis of that, we segregate how harmful the aerosol or the particle is. Now it was a matter of harmfulness, as you talked about. What could be the diseases which could be caused out of these aerosols?
There are several diseases, starting from some normal diseases to chronic diseases, short-term diseases to long-term diseases. The first thing, suppose if you are moving in a polluted area, let it be ITO or somewhere in Delhi. So the first disease or the first problem that you can get after coming back is, you yourself can observe, you start sneezing sometimes and your eyes turn black. I mean the particles gets deposited into the eyes, as well as you start sneezing because it irritates your nose. I mean this is the short-term problem. Apart from that, if you are residing in an area where you are inhaling the pollution every day and continuously for a longer period, this can give some major diseases. It can be started as the mainly these are lungs diseases, either it is bronchitis, asthma, and sometimes some chronic diseases. It can be even lungs cancer etc. Even the pollution level or the air pollution has been related with the chronic lungs cancers also.
Sometimes we have also seen that and also heard about it is prevalent also that skin diseases are on the rise. Can we say that these pollutants are harmful for skin also?
Yes, it can be harmful, but I don't think that it has some direct relationship with the skin diseases. Skin diseases, I mean, it depends upon the dryness, etc. But as far as the pollution is concerned, they are so far, I think as far as my information is concerned, skin diseases have not been related with the air pollution, but the lungs diseases, etc. have already been. Lungs diseases as well as heart problems, as well as respiratory problems.
Because all they are connected to the inhaling and exhaling of the air, and air containing all these particles are harmful.
These have relevance with the air pollution.
Now this a question arises, we are often talking about that there has been a lot of climatic change. If we go about a few decades back, there have been not such climatic change as we are facing today, and we are saying that it is causing, that is the pollution causes the global warming, and that is the only reason for the climatic change. Does this aerosol or the, if we talk about the pollutants, do they have any contribution in global warming?
Yes, definitely. You know, now we go into the details of global warming. We must know what are the causative agents of the global warming. So global warming is what? Is basically warming of the atmosphere or the globe. So what are those factors which are responsible for the warming of the globes? There are some gases, they are known as global warming gases like carbon dioxide, methane, nitrous oxide, various organic gases. It has also been found that aerosols also do contribute in the global warming. Air pollution also contribute as far as the global warming is concerned. It is also a kind of warming agent. Depends upon the nature of the aerosols. I mean, nature means its composition. What kind of composition? Some researchers have also found that if it is black carbon, I mean the particles which is of which is of organic nature but black in color, they are responsible for the global cooling. So these aerosols, on one hand, they are responsible for the global warming. Depending upon its composition, they can also be responsible for the global cooling.
So it is all on the human being how to control the environment and cause these pollutions less. And what about your say on the ozone depletion? Does again there is some connectivity?
Well, ozone depletion, as far as ozone depletion is concerned, this aerosols do not play in ozone depletion, but there could be some secondary gases which might be formed from the aerosols or air pollution, and they are actually responsible for they can be responsible for the depletion of the ozone.
Now a question arises, we always say that obviously the pollutants are bad for the environment. Are there any pollutants, or are there any, can we say that they are sometimes good for the environment also?
Air pollution?
Not basically the air pollution in itself is the baddest thing for the environment, for the human race.
Air pollutions are never good for the health. Yes, as far as aerosols are concerned, they are sometimes really good, like, you know, we have some kind of, I don't actually remember the name of that instrument that is used for asthmatic people. They actually press and they breathe. What is the name of that instrument? I think
inhaler
kind of thing.
Yes, exactly.
That actually generates the aerosols. Aerosols are basically, although they are very small in size, they appear to be small, but they have a larger surface area. So what happens? This physics, actually, the surface area physics basically helps the people to overcome if he has some kind of asthmatic attack. There is basically aerosols, and these aerosols are also used in various medicines.
Okay. Thus we can say that although it has harmful effects, but somewhere
aerosols are applied in for good reasons also.
So now I just want to know what could be the preventive measures, though controlling aerosols, or we can't stop aerosols to be formed in the environment or in the air, but still what could be the preventive measures?
Yes, people have to be very, very alert. Sometimes even if I drive car, if it is a red light, I switch it off, because suppose if we have to wait for, sometimes it is 2 minutes, sometimes it is 80 seconds or so. If we turn on the engines, what will happen? Definitely the car will start creating the aerosols, and that is actually unnecessary. That is not needed. If we switch off the engine, we are contributing for not generating the aerosols. And apart from that, the policy makers have to be very, very strong, and they have to take decisions. The major aerosols generator have to be controlled. Like sometimes back, the Supreme Court of India, they ordered that diesel run buses should be phased out. They have to go out of Delhi. Initially they resisted a lot, but the court was adamant, no, you will have to go. So finally the diesel buses were converted into the CNG buses. So what happens? Definitely it has a good impact on the atmosphere of Delhi, because the diesel buses are, as far as the aerosols amount is concerned, among the diesel buses and the CNG buses, diesel buses emit more aerosols than that of CNG buses. So it was a good move. So citizens have to play very important role, as well as the policy makers or the government have to play also a very significant role. Then something good can be done to mitigate or to control the air pollution.
This was regarding the policy, what could be done, but on the part of the common man, what would be your say? Because each one should have to come forward and make efforts so that we can live in a pollution-free country, pollution-free India. So what do you feel?
Naturally, one has to be very careful as far as their domestic users is concerned. Nowadays, since most of the people are using in their kitchen the gas stoves definitely emits very less amount of air pollution, but their car, their scooter, it has to be serviced properly, it has to be serviced regularly, so that they can emit less amount of aerosols. Apart from these, one thing that we often observe in Delhi, the garbages, what happens, the sweepers etc., sometimes after collecting the garbage, they burn it. On the buses etc., which are at the roadside, they also burn it. So this is not a good method, because what will happen, it will create the aerosol, it will generate the air pollution instead of mitigating it. But there are different methods to dispose of those garbages and the buses. So it is not good. As a common man, if we see such kind of instance, such kind of things, we must ask them not to do it.
So what could be the alternative? If we can say that they are the biodegradable substances, they can be
they should not burn, it should be disposed of properly where it is supposed to be. Instead of burning it at the road, it must be disposed of somewhere. There, for for every garbage, there are specified methods for its disposal. If you go to the net, you'll find if it is a polythene, what is the method of its disposal. If it is a paper, what is the method of its disposal. If it is an organic waste, what is the method of its disposal. So, but people, just for the sake of convenience and just to save their time, they burn it.
Save time, and they think that by burning will keep the environment clean, but in some way or the another, the particles it will raise will get stick to somewhere.
And it is for permanent. Suppose if it is coming to the atmosphere, they are there for hundreds of, tens of years,
Sir, apart from building or creating these policies, do you feel so the public forums are required to be arranged from time to time, because there is a lack of awareness which is required to be implemented?
Naturally, people are nowadays public forum are basically confined mostly to the water pollution, if there is a case of water problem, or if there is a case of garbage, solid waste disposal, etc., or the garbage disposal. But as far as air pollution are concerned, the public forums, you will observe very less public forums, but it is also mandatory. We can't stop breathing. Just see the case of China, Shanghai. It was so heavily polluted that the government was forced to ask the citizens not to come out of their houses. The children and elderlies were especially instructed to keep inside their houses, and they have made some oxygen booths. So if someone is going over here and if he or she is feeling suffocated, she or he can go into the booth, put some coin, give some money, and can breathe normally. So let us not such type of situation come, and before that we'll have to try to overcome these problems as soon as possible.
And people have to create some community level forums also. Many a times I've seen
Definitely
that
it
in
is.
their societies and communities, people get themselves into the garbage, they collect garbage themselves
And
and
they
then dispose them off. Do you feel so that community level it should be done?
Yes, it is good. It is very, very good. Disposal of garbages are really required, but properly, in a manner that it is supposed to be. Not like that, since it has to be disposed, so apply whatever method, whatever convenient method is there, we can apply that method.
And if we talk about the subject environmental studies, do you feel so it has been growing very good, in a good sense it is growing well, because lots of students are coming forward and opting for environmental studies for their career?
Yes, it is the need of present day. If we not adopt it as a subject, as a mandatory subject, then we'll have to regret, we'll have to repent upon afterwards. So it is naturally, it has become the need of time that one has to be alert, one has to be careful, and how it can come through the education at various levels.
At various levels.
So if it is the primary level or school level or at the higher level, it has to be in fact it must be there.
Because we have seen that now at the school level only the environmental studies, not as a studies but as a chapters has been incorporated in the curriculum. So what are the scopes for the students?
There are many scopes, Nowadays there are many opportunities in the government sector as well as private sectors, More or less all the industries which are having some kind of, if they are potential pollution generator, they'll have to keep one environmental scientist or more than one environmental scientist. So all the industries are such kind of industries, they employ people, those who are masters or PhDs or MTech or MPhil. For example, like cement industry, it is mandatory for them. Wherever they have their setup, they'll have to have 1 or 2 employees. If it is a paper mill, if it is chemical, if it is paint industry, etc., all of them. Nowadays, even electronic industries, they will also have to have some environmental scientist or environmental engineer.
Definitely, sir. Thank you so very much for delivering such a nice lecture and making our students aware how could they keep their environment clean and as well as opt for environmental studies as their career. Thank you so very much. And I would like to tell you that Dr. Arun Srivastav would be again with us tomorrow, and he would be giving more deep analysis on air pollution. Thank you, sir. Thank you very much for being with us.